So in this particular podcast, I'm looking at some more details that you need to know about quadratics, okay? One of them, if you remember what a parabola is from the last podcast. A parabola is a symmetrical curve of the quadratic function. So what's the quadratic function again? Remember this? F of x has to have an x squared in it. Done. That's quadratic. The rest of the stuff, you can have all kinds of stuff behind it. That's fine. As long as it has an x squared, you've got a quadratic, which gives you a U-shaped looking graph. Now, this U-shaped looking graph has a couple things. It's symmetrical. What does that mean? You can divide it right in half like this, and this half and this half are exactly the same. They're just mirror images of each other. Now, the other thing we talked about in the last podcast is this idea of the vertex. This, in this case, when it's opening upwards, and this goes on forever, this is the lowest point. That's the vertex, okay? Now, if we have one going the other direction, opening downwards, this goes on forever and ever, but you'll notice it hits a maximum value, and that in fact is the vertex as well. So that's what we're going to be looking at in this particular podcast. So we're going to look at specifics now. Now that we got the general idea of a parabola being symmetrical, and again, even if it's opening downwards, look, it's still symmetrical, okay? So we've got a parabola, symmetrical curve, a quadratic function. We know what the vertex is. Now we have to start getting nitty-gritty about things. One of the things that we have to talk about is something called the maximum value here. The maximum value here is for a quadratic that looks like this. Why? Because it's opening downwards. It's going forever and ever in the downwards direction. But if you think about it, it goes up, 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 up. It reaches a top part, and then it starts to go down. That, of course, is called the maximum. So look at the definition of this. It says the greatest value of the range of the function, not of the domain of the function. We're talking about going up and down. Up and down in math means range. And it says for a quadratic function that opens downward, it's the y coordinate of the vertex. What do I mean by that? Well, take a look at this particular thing. Here's our diagram from the last podcast, and look how I've got a beautiful parabola sitting right here and doing some really nice stuff for us. Okay, that being said, watch this. Look at the vertex. 1, 2, 3, 4, 1, 2, 3. The vertex is 4, 3. Okay, now look, what's the highest point that it goes to? The highest point is 3. That's your maximum value. Y equals to 3. Done. Okay, now look at this one. Look at this next one. And before I get into axis of symmetry, I want to show you something else here. Look all the way down here. It says minimum value. Why? Because you're looking at this parabola now that's going this way to here, opening upwards. So that continues forever and ever, but it gets to a small value here. Now, I can't see what that vertex is. Oh, there it is. Look, 1, 2, 3, 4. That's -4, comma, 1, 2, 3, -3. There's your vertex. So again, what is the lowest point of this graph? The lowest point of this graph is -3. So your minimum value for this would be equal to -3. There it goes. Okay? Now, the other thing that we have to talk about is something called the axis of symmetry. We talked about parabolas being symmetrical, but we never discussed this as an axis of symmetry, okay? Look, the axis of symmetry is a line through the vertex that divides the graph into two equal, or what we call congruent halves. And this is the x coordinate, okay? But notice this is the axis of symmetry. So in other words, we have to set it up as an equation. What does that mean? Really, really simple. All you have to do is say x equals to, tell me what that x coordinate is, and you're good to go. Okay, so let's go back to our two beautiful parabolas that we have here. Notice the vertex, -4, -3. We said the -3 is our min value. But look at this. If I actually put an axis right through here, a nice dotted line, split it right in half, look where I'm splitting it. I'm splitting it right through the -4. Right there, look, splitting it right through the -4. Check this out, okay? So our axis of symmetry on this particular parabola is called x equals to -4. right? Look at the one that we did over here. Again, same idea. No, 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 no. There's our axis of symmetry. And what is it going through? It's going through 4. So we would say the axis of symmetry, okay, is x equaling to 4, right? So the idea of the vertex tells us a lot of information. It tells us the maximum value, or in this case, the minimum value, okay? And it also tells us the axis of symmetry. Where is this parabola symmetrical? And that's going to really open up the door to some really interesting stuff coming up.